Today, we're going to model a gas expander in Aspen HYSYS. Let's jump right in and see how it works.
So first up, what even is an expander? Basically, it just drops a gas's pressure to produce work. Okay, here's our mission. We have a stream of high-pressure natural gas heading into this expander. And the big question is, what's the outlet temperature going to be? Let's build this model and find out. First things first, we need to define our components and pick our property package. Peng-Robinson it is. All right, with our basis all set, we can hop into the main simulation environment and start building. We'll start by plugging in our feed stream conditions: temperature, pressure, flow, and its composition. Next up, we just grab the expander unit from the pallet and hook up our natural gas stream to it. And here's what that looks like. We set the natural gas stream as the inlet and define our outputs. Okay, the simulation needs two more key inputs to solve this puzzle. What are they? First up is isentropic efficiency. The problem states our expander is only running at 30% efficiency. So we just pop that 30% value right here on the parameters page in the expander window. And the last piece of the puzzle we need? That's going to be the target outlet pressure. The problem tells us the outlet pressure from the expander will be 5 bar. Simple enough. And just like that, with all our data plugged in, the software solves it. Let's check the worksheet. There it is. The final outlet temperature is minus 6.19 degrees Celsius. Pretty chilly. So, what does this number actually tell us? Well, it's a perfect illustration of a core thermodynamic principle. I mean, think about it. The gas went in at room temperature and came out way below freezing. That's a total temperature drop of 31 degrees Celsius. That's a huge change from one process. And what's really wild is that this huge cooling effect came from a machine that was only 30% efficient. So it makes you wonder, right, if 30% efficiency can do all this. What happens at, say, 80%?